Welcome dear students, this lecture is about the Kolbes electrolytic method for the preparation of alkanes. It is a method which involves the electrolysis of the concentrated aqueous solution of the sodium or potassium salt of the monocarboxylic acid. This is the setup you have already studied in the electrochemistry, that the electrolyte is there, which is the concentrated aqueous solution of the sodium or potassium salt of monocarboxylic acid. Electrode which is connected to negative end of the battery, that is cathode. The electrode connected to positive end of the battery, that is anode. When we will pass current through this concentrated solution through these electrodes, then we will get alkane. Now let us look into the reaction, that how this electrolysis takes place. First of all, we have a concentrated aqueous solution of sodium salt of the monocarboxylic acid. To differentiate the reaction from hydrolysis, we will write down the term electrolysis on this arrow. Now, my dear students, what happens when the current is passed? These two hydrogen atoms, they combine to form H2 gas. Now, these CO2, they will combine to form two molecules of carbon dioxide. Now, the two sodium, they will combine with two OH to form the caustic soda. And finally, there are two alkyl groups that will join to form an alkane. So in this way, you can prepare an alkane by the electrolysis of the concentrated aqueous solution of the sodium salt or potassium salt of the monocarboxylic acid. My dear students, this alkane is our main product, or you can say desired product. While this caustic soda, H2 and CO2, these are all byproducts, undesired products. So among these undesired products, there are two gases and a base. These gases, they are easily removed because they will escape from the reaction mixer, and then in the reaction mixer you will get the aqueous solution of the caustic soda along with the alkane. Now let us talk about the mechanism of this Kolbes electrolytic method. In mechanism, when you will dissolve the sodium or potassium salt of the monocarboxylic acid in water, first of all, it will get ionized. So first of all, the ionization takes place in water, and this ionization will be a reversible process. You will get two sodium ions and 2 moles of the carboxylate ion. So cations and anions are produced when this ionic compound, which is actually the sodium salt of the monocarboxylic acid, that gets dissolved in water. Now, my dear students, when these ions are produced, then the process of the electrolysis starts. At anode, anode is the electrode which is positively charged because it is connected with the positive end of the battery. So these negative ions, they will travel towards the anode. They will be attracted by the anode and they will get oxidized. My dear students, these negative charge, this negative charge shows that it has extra electrons. So there will be two extra electrons in this ion. These two extra electrons are lost, and then all atoms in this negative ion, they have their valencies satisfied, but this oxygen atom has only one bond, so it will be having one unshared electron and it will be changed to the free radical. So in the first step, the negative carboxylate ions, they will travel towards anode, they will be attracted by anode, and after losing two electrons, they will be oxidized and the negative ion will be changed to the free radical. Now, my dear students, to get stability, now this oxygen will share one electron with carbon, and there is single bond. After sharing one electron with carbon, then a double bond will be formed, and this bond has two shared electrons. So carbon will take its shared electron from this alkyl group and it will share that electron with the oxygen atom. When this electron will be shared with this oxygen atom, you will get 2 moles of carbon dioxide. So you will get 2 moles of the CO2. Just to show and to make it simple for you, I have written it in this form. Otherwise, the molecule of the CO2 is linear. And then these two alkyl groups, they will be having one unshared electron each. So basically, two alkyl free radicals are produced. And now again, to get stable, these two alkyl free radicals, they will share electron with each other and alkane will be produced. So you are required to memorize that there are two products which are produced at the anode. One of them is the CO2 and the second one is the alkane. So your main product is always produced at the anode. Now my dear students, at cathode, you know that cathode is the electrode at which reduction reaction takes place. There are two water molecules at cathode. They will be reduced by these two electrons which were released by this anion. And my dear students, the two hydrogen atoms, they will join together to form H2 gas, and these OH, they will get two electrons and they will be changed to 2OH negative. So in this way, the water molecules that will be reduced, and these 2OH negative, they will join with two sodium ions which are present in the reaction mixer, and they will form 2NaOH. So at cathode, there are two products which are formed. One is the hydrogen gas, other is the base, and both of them, they are the byproducts. So your main product is actually obtained at the anode. Now, my dear students, this reaction, the Kolbes electrolytic method, it has some disadvantages. The first disadvantage is the large number of the byproducts. You know, in chemistry, a reaction is not considered as suitable if it has a main product with large number of the byproducts, because the separation becomes difficult of the main product from the byproducts. So the first limitation is the large number of the byproducts in the reaction mixer. The second limitation is that during Kolbes electrolytic method, when these two alkyl groups, they will join together, you will get only symmetrical alkanes. And symmetrical alkanes are those that have even number of carbon atoms. So you will not be able to prepare methane by using the Kolbes electrolytic method, or propane, or pentane, or heptane. All those alkanes that are unsymmetrical or which have odd number of the carbon atoms, they cannot be prepared by using the Kolbes electrolytic method. Now finally, let us look into an example of the reaction. For example, if these alkyl groups are actually methyl groups, and this one is the sodium acetate, mean the sodium salt of the acetic acid. When that will be electrolyzed, what kind of alkane you will get? Here the two alkyl groups, they will be methyl group. So you will get an ethane. It is an example of the Kolbes electrolytic method. What we have discussed earlier, that was the general reaction and general mechanism. But when you will specify the alkyl group, then it will become an example. And in this example, the sodium salt of the acetic acid that is being electrolyzed, and you will get ethane. So, Kolb's electrolytic method is an outdated method nowadays because of its two limitations. First is the large number of the byproducts, and second is the preparation of only symmetrical alkanes. So, it was all about the Kolb's electrolytic method. If you find any problem in understanding this topic, you can ask in the comment section. I will definitely answer you. Till then, take care.